Number 5. Additive inverse. What is additive inverse property? Let A be any set where A belongs to A. There exists a number A prime belongs to A such that A plus A prime equals to A prime plus A equals to 0, which belongs to A. Then set A satisfies the additive inverse law. For the additive inverse property, we just let A any set, like it can be a set of natural numbers, can be whole numbers, can be integer, can be real numbers, where the element A belongs to A. A must be the part of set A. But there exists another number which is A prime, which also belongs to A, such that A plus A prime equals to A prime plus A equals to 0 belongs to A. What is A prime? A prime is negative of A. Like if we have positive A prime will be negative A. If we have negative A prime will be positive A. So it is inverse. That's what we call it additive inverse. We take the inverse of the addition. We have addition here. That's why we call it additive inverse property. For example, if we have 2 here, we're gonna have A prime will be negative 2. So negative 2 times positive will be negative 2. 2 minus 2 will be 0. Similarly, negative 2 plus 2 will be 0. So ultimately my answer will be 0. 0 should also belong to set A. So just keep this in your mind that A prime is a negative value. We have to look to 3 areas here. Number 1, A must belong to A prime belongs to A. Like this negative value which is A prime should also exist in set A. A should exist in set A. Finally 0 also exists in set A. So what are the sets who cover 0 and negative values? Additive inverse property is applicable for all the below sets except natural numbers, whole numbers, and irrational numbers. If we have set of natural numbers, set of whole numbers, set of real numbers, set of integers, set of rational numbers, and set of irrational numbers, it doesn't work for the natural numbers, and also doesn't work for the whole numbers. It also doesn't work for the irrational numbers. We have used addition binary operation. It is according to the addition binary operation that we have used in the additive inverse property. As I told you, we have to check 2 areas. One was that A belongs to set A. We have no issue there. A can be any element from any set. But we have issue here with the A prime. A prime is a negative value. What are the sets who don't have negative values? What are the sets who have negative values? This is the one thing. The third thing is that A plus A prime equals to 0. We have 0 finally. A plus A prime equals to A prime plus A equals to 0. 0 must belong to set A. The main issue is here with the 0 and with the negative values. What are the sets who don't have 0 and negative values? What are the sets that won't be a part of this property? But what are the sets who have 0 and negative values? They will be the part of additive inverse property. When you look to the set of natural numbers starts from 1 up to positive infinity, all the values. So 0 is not the part of natural numbers. This is the one thing that where we have failed. Second thing is the negative value, which is A prime. A prime is a negative value. It should also belong to set of natural numbers. Is there any negative value in natural numbers? No, there is no negative value. All the values, all the elements of natural numbers are positive. Again, we have failed here. We have failed here in 2 things. One is the 0 which does not belong to n. Second one is A prime, which is negative value. Negative value does not belong to n. So additive inverse property is not applicable for the set of natural numbers. Similarly, when you look to W is the set of whole numbers. We have no issue with the A. A can be the element of W, can be the element of whole number. A can be whole number, but we have issue here. Similarly, we have no issue with the 0. 0 exists here in the whole number. We have no problem with the 0, but we have 0 with the A prime. A prime is a negative value. Is there any negative value in the whole numbers? No. There is no negative values in the set of whole numbers. Whole number starts from 0, 1, 2, 3, 4 up to positive infinity. There is no negative number inside the set of whole numbers. So there we have failed. Therefore, we can write that additive inverse property is not applicable for the set of whole numbers. But what about the set of real numbers? It works for the set of real numbers because remember, real numbers is the set of union of rational and irrational numbers. So it covers all the rational and all the irrational numbers. We know that 0 is a part of rational numbers because all integers come inside the rational numbers. So 0 belongs to R, and similarly negative value, a prime, which is negative value. In this set we have positive values, we have negative values, we have values in the fractional form, we have values in the root form. The set of real number covers everything. Therefore, additive inverse is applicable for the set of real numbers. Similarly, when you look to the integer, what is integer? Integer covers 0 and also both positive and negative values. 0 belongs to Z and also negative numbers belong to Z. So additive inverse property is applicable for the set of integers. What about rational number? We know that all the integers, whether they are positive, whether they are negative, including 0, come under the set of rational numbers. And also the number in fractional form like 1/2, 1/6, -8/5, 0.04, and so on. So we can write that 0 belongs to rational number, negative values belongs to rational number. Therefore, additive inverse property is applicable for the set of rational numbers. But what about irrational numbers? We have no issue with the A. Elements A can belong to set of irrational numbers. And also we may have negative numbers like -5 under root, -2 under root, -1/7 under root. So here we have no issue with the A prime as well, but we have issue with the 0. We know that according to the additive inverse property, A prime plus A equals to 0. 0 should also belong to set of irrational numbers. But actually 0 is not the part of irrational numbers. 0 does not belong to set of irrational numbers. Therefore, we can write that additive inverse property is not applicable for the set of irrational numbers. By using the addition binary operation, additive inverse property is applicable for these sets except the set of natural numbers, the set of whole numbers, the set of natural numbers, the set of whole numbers, the set of irrational numbers.